Dear students, I am Mahesh Javalkar of Maratha Mandal Polytechnic, and today I am posting my fourth video on analog electronic circuits subject, first chapter, that is power supplies. And today in this video I am going to tell you what is a regulator, need for voltage regulator, Zener diode voltage regulator, line regulation and load regulation. So let's start with the outlines of this presentation. The first one is need for a regulator. The second one is line regulator and load regulator definition. The third one is how we are using Zener diode as a voltage regulator. And fourth one will be the circuit of Zener diode voltage regulator. Okay. So let's start with the reasoning. Why do we need a regulator? Okay. Now, here, why do we need a regulator? Instead of that, if we don't use a regulator, what happens? If we don't use a regulator, if the input varies, the output also varies. If the load varies, the output also varies. This is with respect to power supply we are speaking. Okay. That is why we require a regulator. So for a power supply to produce a constant output voltage, irrespective of input voltage variation or the load current variation, there is a need for a voltage regulator. That is why we require a voltage regulator, because a constant perfect voltage for an electronic circuit or electronic appliance is very important. The applied power supply should not vary for any electronic circuit or electronic appliance. Otherwise, it will malfunction. It will not function properly. That is why we require a voltage regulator. Okay. So a voltage regulator is a circuit or a device that maintains constant output voltage in spite of any fluctuations in the input voltage being applied or any variations in the current drawn by the load. This is what is the definition of the voltage regulator and why do we require a voltage regulator. Okay. Then in voltage regulation, there are two types. One is called as line regulator and the other one is called as load regulator. So in line regulator, what will happen? The output voltage will remain constant in spite of variation in the input voltage, input line variations. Okay. In spite of variation in the input, the output voltage remains constant. And in load regulations, what will happen is the output voltage will remain constant in spite of variation in the load. In spite of variation in the load. That is called as load regulation. Okay. Now with this, we will go to see Zener diode. And now why Zener diode is used as a regulator. Okay. So if you see a note over here, a Zener voltage regulator is one which uses Zener diode for regulating the output voltage. When the Zener diode is operated in the breakdown or Zener region, the voltage across it is constant. A large change of current through it will be flowing, but the voltage will remain constant. This characteristics of Zener diode makes it a good voltage regulator. Okay. So whenever we are using Zener diode as a voltage regulator, we should think that Zener diode is connected in a reverse bias condition, and in reverse bias condition, as the applied reverse voltage increases, then it reaches to some Zener breakdown value, say 6 volt or 12 volt. In that case, the voltage will remain constant across the Zener diode and the current will go on increasing even if you increase the applied voltage. Now, this characteristics of sharp breakdown in the reverse bias of Zener diode is used in the voltage regulation. Okay. Then we'll go to see the circuit of Zener diode voltage regulator. So here if you see, as shown in the circuit, the applied voltage is applied here. This is plus and this is minus. So this is your applied voltage V in. Okay, applied voltage V in. Now, if you see that V in plus, that is positive, is connected to the cathode of the Zener diode. This is a Zener diode here. This is a Zener diode. So here is the cathode of Zener diode and here is the anode of Zener diode. Okay. So here, this is cathode is connected to positive terminal and anode is connected to negative terminal. That means it is reverse bias condition. This is reverse bias condition for Zener diode. Okay. Now here you see RS is the source or resistance, IS is the source current, IZ is the Zener current which is going to flow through the Zener diode, IL is the load current which is going to flow through the load RL, and RL will be the load which will be varying. Okay, and V out will be equal to RL into IL. This is V out which will be equal to IL into RL. Okay. Now here, say first thing what you should know is the reverse bias condition of Zener diode. If you see that condition what you have studied in semiconductor devices, so here this is the 0 point and this is your reverse voltage applied and this is the reverse current which is going to flow. So initially when you apply the voltage, it will give you a leakage current, and after some time when the applied voltage reaches certain point, the voltage remains constant. The voltage remains constant, that is called as Zener voltage, and the current will go on increasing. Okay, even if the input voltage go on increasing. So this is your current IZ and this is your voltage VZ. Okay, so this is the Zener voltage, and practically the value of Zener voltage can be around 6 volt or 12 volt. Any Zener you can use FZ12 or FZ6. Okay, now here this a property of Zener diode where the current varies but the voltage remain constant. This sharp breakdown, this is used for regulation of voltage. This is used for a regulation of voltage, and this is your sharp breakdown, what you can see, and this is the Zener breakdown, which is used for a regulation of voltage. Okay. Now, while explaining this circuit, first we should consider what is line regulation. Line regulation. Line regulation. Okay. Now here for line regulation students, we will see what happens at the node over here. Okay, what happens at the node over here? This is the node. At this node, you see that the source current IS is equal to Zener current plus load current. Okay, this is one condition what is there according to your KCL. And second condition, what is in the definition of line regulation is that your input voltage is going to vary, whereas your output voltage is going to remain constant. Okay. Now, if the input voltage varies, that means if V in varies, okay, V in varies, that means the source current IS will vary. If the source current IS varies, okay, if the source current IS varies, and you know that IS is equal to IZ plus IL, and you want IL to remain constant. IL to remain constant because IL into RL will be equal to your voltage output. So you want this to be constant. Now, if IS increases and if you want IL to remain constant, then IZ has to compensate. IZ has to compensate in the area of that sharp breakdown. So in that Zener breakdown area, IZ will adjust itself. It can become less or more, and it will see that IL is constant so that the product IL into RL, which is output voltage, remains constant. That means in line regulation, we will be explaining that even when the input voltage V in varies, the output voltage V out, that is IL into RL, will remain constant because the Zener diode, across the Zener diode, the voltage will remain constant and the current can vary, and that is the feature of the Zener diode. So IZ will compensate itself and it will see that load current IL remains constant, so that IL into RL will be a constant parameter. So output voltage will remain constant. Similarly, if you go to the second type of regulation, which will be called as load regulation. Second will be load regulation. Load regulation. Now, in this case, the our condition is that V in is constant. V in is constant. Okay, that means IS is constant. And we know that Is is equal to I Z plus IL. Okay. Now here if the load varies, if RL becomes less, then IL will increase. Or if RL becomes more, IL will decrease. IL will decrease. Okay. So IL and RL, that is current through the load, will vary according to variation in the load. Now, if there is a variation in the load, if there is a variation in the load, then IL will vary. Now, to compensate this IL, IZ will adjust itself. IZ will adjust itself. That means the Zener current feature of the Zener diode in reverse bias condition will adjust itself, and it will see that as the load varies, IL also varies, and the product of them, IL into RL, that is V naught, which should remain constant. So IL into RL in any condition should remain constant. So in that case, it is called as load regulation. So here what is happening is your input voltage remains constant, whereas your load is going to vary. Because your load is going to vary, or load current is going to vary, and because load current is going to vary, your Zener current IZ, which is flowing through the Zener diode, will compensate and see that the product IL into RL remains constant. That means in this condition also the output voltage remains constant. Okay. So this is a circuit of Zener diode voltage regulator, and this is what you have to explain whenever you draw this circuit, okay, of Zener diode, and how Zener diode is used as a voltage regulator. Then if you see the note on that, Zener diode is one of the specially designed diodes that predominantly works in reverse bias conditions. They are more heavily doped than ordinary diodes, due to which they have narrow depletion region. While regular diodes get damaged when the voltage across them exceeds the reverse breakdown voltage, Zener diode work exclusively in this region. The depletion region in Zener diode goes back to its normal state when the reverse voltage gets removed. This particular property of Zener diode makes it useful as a voltage regulator. Okay, so that is what we have already told in our explanation when we were explaining the circuit. Now, in that circuit only, if you want to explain what is line regulation, you can tell that in this type of regulation, series resistance and load resistance are fixed. Only input voltage will vary. Okay, and output voltage will remain constant as long as the input voltage is maintained above a minimum value, that is the Zener value. Okay, similarly, you can also define what is load regulation. In this type of regulation, input voltage is constant and the load resistance is varying. Output voltage will remain same as long as the load resistance is maintained above a minimum value, and there also the Zener current will compensate itself, and it will adjust with the load current, and it will see that the load current multiplied by the load resistance, that output voltage remains constant. Okay, so this is how a Zener diode can be used as a voltage regulator, which will give you a constant output voltage in spite of variations in the input voltage, or in spite of variations in the load resistance. Okay, so this is what is explained in this presentation. So we have seen what is a voltage regulator, why do we need a voltage regulator, how Zener diode is used as a voltage regulator, and what is line regulation and what is load regulation. Okay, students. So with this, I end my presentation here. If you are having any doubts or any feedback, if you want to give, you can just call me or you can ask me, and I will clear your doubts. Okay. Thank you very much.